In our previous session, we mentioned how the kinetic theory of gases states that gases are always in constant random motion and how the kinetic energy of these gases is directly proportional to the temperature. In this session, we get to use this kinetic theory to explain the three gas laws, which are Boyles Law, Charles's Law, and Pressure Law, coming up. We'll begin straight away with Boyle's Law. We all know that Boyle's Law has this kind of relationship between pressure and volume. It states that pressure and volume have an inverse relationship, or you may call it that the pressure of a fixed mass of a gas is inversely proportional to its volume. It means that when pressure is increasing, volume is decreasing. And when volume is increasing, pressure is reducing. These two have an inverse relationship. So how do we use the kinetic theory to explain this relationship? Well, let's look at this diagram. This is a diagram of, let's say it's a container with a piston. This right here is a piston. And in this piston, in here we are having a gas. Now take note, this gas is a fixed mass of a gas we are dealing with right here. When we push in this piston right here, we are increasing the pressure of this gas, and of course when we pull this piston out there, we are reducing the pressure of this gas. And definitely, of course, when we push in this piston right there, we are squeezing these particles to occupy a smaller volume, meaning that when we push in this piston, it means that the volume of this container is going to reduce. And of course when we pull it out, it means that we are reducing the pressure on these gases, we are easing the pressure on these gases, and definitely the volume of this container will increase. So how do we explain this theory? When we relate this to the kinetic theory, which states that these particles are always in constant random motion and that these particles, their kinetic energy is directly proportional to the temperature, when we, let's say, reduce the volume of this gas, when we reduce the volume by pushing this piston, it means that these particles right there are going to come closer to each other. As these particles of these gases are coming closer to each other, it means that they are going to be colliding with the walls of the container more often than when they are spread far apart. Now, because the rate at which these particles are colliding with the walls of the container is going to increase as a result of this reduction in volume, it definitely means that the pressure increases. Remember, the pressure of an ideal gas, as this is accounted for by the rate at which these particles are colliding with the walls of the container. So because upon reducing the volume of this container, the rate at which these particles collide with the walls of the container increases. That is what accounts for the increase in pressure. Now remember that when it comes to Boyle's Law, as pressure and volume are relating, the condition here is that temperature has to be constant. So we can go ahead and in conclusion I can say that at constant temperature the kinetic energy of the gas molecules is constant. A reduction in volume will reduce, or it will shorten the distance between the collisions, and thereby increasing the rate of collision and the rate of change of momentum of these particles as they collide with the walls of the container. This increase in the rate of collision of these particles with the walls of the container is what increases the pressure of the ideal gas. So we've explained Boyle's Law. Let's go on to the next law, Charles's Law. Now, if we may remind ourselves, Charles's Law is volume and temperature. The higher the volume, the higher the temperature. The lower the volume, the lower the temperature. Now, the volume of a fixed mass of a gas is inversely proportional? No, it's not inversely proportional. It is directly proportional to the absolute temperature. Now, of course, when it comes to Charles's Law, the condition here is that pressure has to be kept constant. So the volume of a fixed mass of a gas is directly proportional to the absolute temperature of that gas, on condition that the pressure is held constant. That is Charles's law, call it the law of volumes. Again, to explain this law, looking at the kinetic theory, I'll still use a diagram. We shall use this illustration. If you look at this, for example, this is a container that is having some gas particles. If I was to increase the temperature of these particles, let's say I subject this to heat right there. As I subject this gas to heat, it means that the temperature of these gas particles is going to increase. Increase in this kinetic energy of these particles because of the increase in temperature means that these particles will be colliding with the walls of the container more often than before. These particles colliding with the walls of this container more often than before means that there's going to be an increase in pressure. Remember, the pressure in a gas is because of the collisions on the walls of the container. If the rate of collisions on the walls of the container increase, it means that the pressure of this is going to increase. But remember, we want to make sure that this thing takes place at constant pressure, because here we are because if the pressure is going to increase as a result of the increase in the particle collisions on the walls of the container, then it would no longer be Charles's law. Charles's law is supposed to take place at constant pressure. So what does this mean then? It means that as these particles collide on the walls of the container, in order for us to ensure that this pressure is kept constant, or in other words, in order to make sure that the rate at which these particles are colliding on the walls of the container remains constant, it would have to mean that the volume of this container will have to increase. When the volume of this container increases, it means that we are compensating for that pending increase in the pressure. So in other words, if we may explain this using the kinetic theory, what I'm trying to say here is this increase in temperature of these molecules is going to increase the rate, or is going to increase the kinetic energy of these particles. And when this kinetic energy of those particles are increased, they are going to collide with the walls of the container with a higher velocity. So the faster the particles move, the higher the rate by which they hit the container walls, therefore an increase in pressure. So if pressure is to be kept constant, which is required by Charles's law, it means that the volume occupied by this ideal gas has to be increased so as to compensate for the increase in particle collision with the walls of the container. The pressure law. Now, of course, we know that the pressure is directly proportional to the temperature. That's according to the pressure law, and this is on condition that the volume is constant. The higher the pressure, the higher the temperature. The lower the pressure, the lower the temperature. So we need to explain this using the kinetic theory. Of course, pressure of a fixed mass of a gas is directly proportional to its absolute temperature on condition that the volume is held constant. How do we explain this using the kinetic theory? We'll use our diagram again. Again, if you look at this diagram, still we are having our gas right there with those specks of particle. This is our ideal gas, and we want to use this explanation to show that P is directly proportional to T. Now, of course, here, since when it comes to the pressure law, the condition is that the volume has to be constant. That simply means that our piston is not going to move. It's going to stay static right there, because this relationship is only true when this piston is not moving, when the volume is constant. So if the volume is constant, if I supplied heat here, supplying heat to these particles or to this ideal gas will mean that the temperature of this will increase. When the temperature of this increases, of course, we are looking at intermolecular forces of attraction loosening or weakening, and of course, when they loosen, it means that the kinetic energy of these particles is going to increase. They are going to become more volatile or more excited. These particles getting more excited means that the rate at which they collide with the walls of this container is going to increase. They will be colliding with the walls of this container more often than before. When these particles collide with the walls of these containers more often, it means that the pressure is increasing. Remember, when it comes to pressure of an ideal gas, the force of these particles as it collides on the walls is what is accounting for the pressure. So it means that if the rate at which these particles are colliding with the walls of this container is high, it means the pressure is high. If the rate at which these particles is colliding with the walls of this container is low, it means that the pressure of that gas is going to be low. So definitely when the temperature is increased, this increase in kinetic energy is what is causing the pressure to increase as a result of those increased collisions. So in other words, we can say that an increase in temperature will cause an increase in the kinetic energy of the molecules, which increases the rate of collision between the molecules and the walls of the container. Now, this increases the rate of change of momentum of the molecules, and as a result, this leads to an increase in pressure. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.